Welcome everyone to today's talk. Just briefly, for those watching online, can you hear me and am I very audible? Just to signify, say something in the chat or maybe throw some symbols or emojis. Am I very audible? Can you hear me? All right, thank you, Moyo. Can you see my screen, my slide? Is it also visible? Okay, the slide is visible, right? All right, I will assume it's visible as well. All right, so thank you everyone for coming to today's talk. My name is Anhui. I'm from the School of USCC, University of Science and Technology of China, and it's my pleasure to present today's talk. I'm very honored to be before you guys. A brief talk about master's student. My research field is computer vision, more specifically in the fire safety. Okay, so I try to optimize architecture for fire safety and the likes. So today we are going to, oh, it's a bit faint. Can you hear me now? Max, is it okay now? I think I won't move far from my PC so you guys can hear. Is it okay now? Thank you. So I will stand here to speak. All right, so I said that just a brief intro about myself. I'm a computer vision researcher at the University of Science and Technology of China. And more specifically, I'm in the domain of fire safety. So really excited to be before you guys. To begin this talk, I'm sure we already know today's title is Why You Need Computer Vision. And more specifically, we are going to look at some real-world applications and tools for research. And not only research, you can use it for your own day-to-day hobbies, right? Okay. So the agenda today will be what computer vision is, why computer vision is, turn off your mic is on here. Okay. Why computer vision matters today, okay? And we are going to also discuss some domain applications, right? And some how to get started. Most of us right now don't know what computer vision is. So how can you start? How can you venture into the artificial intelligence domain? And I will also share some useful tools for you guys, okay? So the big question here is, what is computer vision, right? Is a very important question for this topic. So I lay the question to you, what is computer vision? But more specifically, what can you see in this image before you? Can someone tell me, someone in the audience? What can we see in the image? We can see what? What can we see in the image? Can you see my screen?
Yes, so yes, we can see.
Okay, thank you. So I'm saying, what can you see in the image shared before you? Not the slide. There's an image there, right? Can you see it?
Two different animals, probably different sizes, different breed, and different texture on their skin.
Okay, thank you. How about you guys in the class? What can you see? Please, just, there is no right or wrong answer. Anything, say, please. Oh, I see. Okay. So what we can see, it varies from person to person, right? Someone might say they see cats and dogs, right? And someone else might go further to say they see 2 cats and 2 dogs, okay? And these answers are correct. Someone might even go further to say that these cats and dogs are seated very nicely on the couch, right? So the answers vary, okay? Now, this is because you might or you must have seen a cat and a dog in your lifetime. We are humans, and the way we understand or perceive the real world is based on our past experience, right? As a great philosopher said, tabula rasa, we were born with a blank mind, but we tend to experience what we know, and we tend to know what we experience, and that's what forms our current knowledge, right? So if we pose the same question to a machine, a robot, what do you see? We pose the same question to a robot. What do you think the robot will say? The robot wouldn't know what that is. It's like you are asking a piece of metal, what is this? It doesn't know. So for it to be able to know, you have to teach it. Before you knew that that was a cat, they had to teach you that that was a cat, right? And all of those things. So we need to teach a machine, okay, how to understand visual cues. We need to tell it that this is a cat and this is a dog. We need to train it using some algorithms. And these algorithms then make it wiser to be able to distinguish between a cat and a dog, okay? Visually. Now, when you pose the same question to a trained machine, it is able to know that it's cats and dogs, okay? Visually. So that brings us to the main definition of what computer vision is. Computer vision is simply teaching a machine, okay, how to see the real world, how to perceive the real world. The way you perceive that I am standing before you, a machine does not understand that. You need to show it that this is what this image means. However, there is a problem. The problem lies in the fact that machines don't understand semantics. They don't understand English. Please, whose speaker is on? Please turn it off. I'm echoing. They don't understand. Please. Check yourselves, please. They don't understand English, okay, or language. What do they understand? They understand binary, ones and zeros. So our images, please, who is that?
Okay.
If I'm here, you can mute your stuff. Mute your PCs, please. It's echoing, disturbing the audience. All right. So machines don't understand semantics. They don't understand language. What they understand is binary, ones and zeros. Okay. And to a machine, what we consider an image is someone's. I'm echoing too much. What's wrong? You guys in online, can you hear me well? Is it echoing? Okay, I think it's okay. So they don't understand semantics. They only understand binary ones and zeros. So what we see as image, the machine or the computer sees ones and zeros. They see numbers. They see binary. Okay. Now take, for example, an input image, an image that has an object, like for example, this baby. For a machine to be able to understand that this is a baby, right? We need to perform some operations, some convolutional operations, some dot products to this particular image, okay? And one of the convolutional operation is one of the ways to do that is by performing convolution using a kernel. From the video you watched earlier, you must have seen a detector, right? Or a kernel. A kernel is simply...
Could you please explain the convolution briefly?
Yes, I can. So when we say convolution is simply moving of a kernel or some feature detector across an image to be able to extract features. Features we call features that then become feature maps. We actually try to extract edges. So for example, in the image you are seeing here, I pose a kernel, a 3x3 kernel, okay, that is going to extract some features. For example, if we pass this kernel, and the purpose of this kernel is to extract the edge of the nose of this baby, okay? By the time this kernel passes through convolutionally, meaning it goes across, can you see my mouse? It goes across the baby this way, okay? And as it goes across these pixels, okay, it performs convolution, meaning dot product across the matrices of the image, okay? And that is higher level than this talk. But we pass this particular kernel across the pixels and perform dot product, you know, across the entire pixels. And that gives us a feature map. A feature map is simply a feature that has been extracted from the image that we just performed convolution on. Is that understood?
Okay, so the movement from left to right is one column per step, right?
Yes, depending on how many steps you want. Also, you can add padding, and also you can even add some other techniques. It depends, or max pooling as well, right? It's up to you. Depends on the edge you are trying to get from that image.
Okay, good. Thank you.
Yeah. So please, if you have any questions, please, I would appreciate if you could wait till the end so that we can speed things up. So, as we know, this is simply an image of a baby, but for the machine to understand, we need to actually perform some operations, and then that is the only time the machine begins to understand that this particular image is a baby, because by then we will extract some features in the feature map of this image. And over years, researchers have been able to perform several techniques, get several algorithms, and improve computer vision as a whole, to the point where now, when we talk about pixels, although it's the fundamental of computer vision, okay, it's treated as a screw in a machine. You know, when you want to describe, for example, your mobile phone, you don't always describe the screws, right? Or the nuts, even though they are very important. So pixels are important in computer vision, but they are no longer spoken about the way we used to speak, in the past. Now what we talk about is deep learning, convolutional neural networks, ResNet, all these modern day computer vision techniques is what we use, and we are going to see some reasons why we use them, okay? Now, another question is, why are we talking about computer vision today? Why computer vision? Okay, it's simple. Computer vision is, to a robot or to a machine, is an aspect that provides it with a very rich sensor modality, okay? What does that mean? I know we have several sensors that we can use to operate a machine, but to a machine, providing visual cues adds to its understanding of the world much better than other sensors, okay? Another reason we are studying computer vision today is because of its massive societal impact, okay? There have been lots of improvements in agriculture, in health, in transportation. Right now we have autonomous vehicles, okay? We also have machines that enable the detection of pests and diseases in agriculture, right? In aquaculture, we have machines that detect fishes that are dead and those that are alive to estimate yield. So there's massive societal impact. Another matter, or another reason we should actually study computer vision is it is everywhere, ubiquitous, right? It's everywhere in life. Everyone here has a phone, right? And at one time or the other, you must have edited your image, your picture, right? When you did that, you were performing some operations you didn't know. You see that blur, when you try to blur your image, when you try to increase the saturation, all those things, you are performing computer vision techniques. Okay, so it's everywhere. It's everywhere in vehicles, in factories, even smart cities, right? It's everywhere. Another thing is, right now in this day and age, in 2026, computer vision has come a long way to the point where now we have a very large ecosystem of data sets, of communities. So it is important not to be left out. You need to be part of this community. That's why we are studying computer vision today. Okay. Now, for some people that are interested in what can you gain financially, I bring good news to you. I bring good news to you today. Yes. So I decided to bring out some popular career paths you could take, okay, if you would like to venture into computer vision. So this is why you should know computer vision, okay? It's also part of that. So according to Glassdoor, from 2025 to 2026, if you are an image annotator, okay, in the US, you will earn about $51,000 per year, okay? This is on average. And in China, you will get about 132,000 yuan per year, okay? As an image annotator, just to annotate images. As a computer vision engineer, in China, you will get about 240,000 yuan per year. That's big money, okay? That's about, let's say 12,000 or 20,000 per month, thereabout, right? So it's big money. If you are a lead computer vision engineer, you should be able to earn about $171,000 every year on average. On average, it could be more, it could be less, right? And the list goes on. The list goes on. This to show you that the field of computer vision is not just for research. It can actually benefit you financially, okay? So you need to tap into this very interesting field. You need to tap into it. Now let's go to applications. Applications of computer vision, okay? Computer vision can be applied or has been applied in the field of medicine, okay? Most of you, is any medical student here? Oh, none, right? But I'm sure some people online might be medical students. Okay, so computer vision has been applied in the field of medicine. More specifically, it has been used to detect some abnormalities in the human body. Okay, for example, tumors or lesions in the human body. Okay, and also it can be used to segment or provide specialists with areas of particular concern. For example, your organs like cells, livers, your organs like livers, lungs, your heart, your brain. Okay, computer vision can help give a professional a more insight to all these body parts. Another interesting application in medicine is the ability for computer vision to perform monotonous tasks repeatedly and always provide accurate response. So as we know, when you go to the clinic for a test, say for example, MRI or CT scan or X-ray, it is expected that after you are done with your test, you should take that particular scan or that image to a specialist, right? Someone should look at your X-ray and then tell you what exactly is wrong with you. But in today's day and age, we have machines that can actually tell you what's wrong, okay? And what does this do? Sadly, it will lead to unemployment of some specialists, okay? But it can actually perform this task without the fear of human bias, okay? For example, let's say Mr. Ibrahim is not so good in understanding X-rays, but I'm the best specialist in town. What if I'm sick? What if I'm not in the hospital? Then what happens to the patient? Okay, that is why we need computer vision. Computer vision is there to stand and fill in the gap. Okay, so that is another application in medicine. And there are several resources, for example, Monai, and also there is 3D Slicer. Okay, if you want to train your own model, okay, for example, in medical field, you can use YOLO as well. Okay, these are very important frameworks and tools you can use in medicine. In the field of construction, most of you are civil engineers, right? Exactly. So in the field of construction, we can train a model to be able to detect hard helmets, safety vests, okay? We can be able to detect harness. Are all the workers in the construction sites protected? Okay, we can also be able to track, what is it called, workers, track, we can be able to track people who are sleeping and those that are working hard by the use of computer vision. Okay. Additionally, we can use it to track and detect cracks, corrosions, defects. Okay. So these are the applications in construction. The list goes on. Okay. We can't list them all, but these are just some I just brought for you guys. In agriculture, we can use computer vision to detect fruits, leaves, fruit defect, leaf defect, diseases, pests, weeds. We can be able to apply insecticides. Who's listening? No. We can be able to apply insecticides here. We can be able to apply insecticide at the appropriate amount. Why? Because through computer vision, now we know what particular region is affected by pests. We don't need to spray the entire field to kill the pest or to get rid of weed. We can simply train a model to detect a pest or train a model to detect weed and then go to that particular region and apply insecticide or train a machine to apply it for you. On the right side of this image, you can see, I don't know if you guys can see this image, this GIF. It's a satellite image, okay, gotten of a field. And what the researchers did in that field was to plant several crops for several years. So for example, each year they planted a specific crop. And the aim of doing that was to know what crop provided the highest yield and in what regions were they performing better, okay? As we can see, there are several areas that are green, several areas are yellow, and several areas are red. The areas that are green show that those regions for that particular crop was able to yield more of that crop. For example, say they planted onions and potato, right? Say this year they planted onions in that field and the next year potato. And then they find that, okay, in this year, this particular region was okay for onions. So what happens? Why is the other region not okay for onions? They need to go and investigate. Maybe it could be the soil. The soil in those regions might not or may not be good for onions. So they need to do what? Perform some tasks to improve the soil for onions. So this is another application for computer vision, right? Another application will be in fire safety. This is my domain, right? I told you guys. And we can use it to detect fire, okay? And once we detect fire or segment region that is fire, we can be able to use it to give early warning systems, okay? We can be able to alert firefighters, alert the people who are expected to fight this fire for us and, save lives, properties, and the likes. So this is another benefit of computer vision, okay? Early response. So some other applications, because they are inexhaustive, there's a lot of things we can talk about. So we can use it to detect fishes in aquaculture. We can use it for classroom attendance, okay? We can use it for customer engagement. We can also use it to recognize license plates. The list goes on, okay? The list goes on. If someone is sleeping in this class, I can know using computer vision, okay? I can know. So the list goes on and on. All right. The next step will be to take you guys on a roadmap. At this point, you might be asking, how can I get started? What are the steps I need to take as a beginner or someone who is an intermediate? What can I take? What are the steps? Now, as a beginner, I will advise for a start, I would say this is just my opinion, okay? This is how I started my journey. So I'm just trying to give the suggestion to you guys. As a beginner, we advise that you learn and understand machine learning concepts, the basics. What is a pixel? Why do we need convolutional neural networks? What is a neural network? What are layers? You should be able to know this before you are going to be able to understand how to apply computer vision to a task or a project you want to perform. Also, you need to know a programming language. I will suggest you learn Python. You should also be able to know how to use some libraries like NumPy, Matplotlib, and the likes. These are very important in computer vision. Even OpenCV is very important, okay, as a beginner. At least know the basics. Going further, to be an intermediate, someone who knows computer vision to the intermediate level, I will advise that you know some foundational architecture like ResNet, MobileNet, ShuffleNet. These are very fundamental modules or architecture that you should know, okay, in computer vision. You should also be able to know what detection means. When we say detection, what does it mean? When we say segmentation, what does it mean? You should be able to know this before you can say you are an intermediate, okay, in computer vision, and know the models that can perform those tasks. Next, to be advanced, you should be able to know transformers. What are transformers? When we say transformer, what does that mean? When we say something like squeeze and excitation mechanism, what does that mean? Why do we need them? You should be able to know this. Next, you should be able to know foundational models. The segment anything model, this is a foundational model. It's a model that performs general segmentation for any domain. Can you use it? Can you use it? Can you use it? You can't, okay. You should be able to know it at that step, okay? And then as an expert, you should be able to not only know these things, but be able to deploy them on the edge, on the cloud, on your computer. You should be able to make money from it. That's why you're an expert. Otherwise, you just learned it for nothing, eh? Except you're an hobbyist, right? Okay. Now, another part of how to get started I would like to stress a little will be, how do you perform a project? Say, for example, you've been able to get the basics down, at least the beginner side, and you want to start applying yourself. How would you start as a beginner or as an advanced or an expert? This is a very important workflow. It doesn't have to be exactly like this, but I think this is a practical guide, okay? So say, for example, I start learning OpenCV today, and OpenCV, for example, I download a textbook or I watch a course online, and there is this particular project I saw that involves calculating the frames per second of a video, for example, okay? What is the first thing I need to do? Pick a problem, right? Now, the problem is calculation of frames per second of a video. How do I know of a model, using a model to calculate the frame per second that my model can process a video with? So I have a model and I want to calculate the frame per second that that model can process a video. How can I do this? How can I do this? First, pick that problem, we have the problem. Next, get your data. What is the data in this case? The data is a video. You get a video, right? Go on the internet, download the video, right? Put it on your computer. The next step, label. Now, step 3 and step 4 only goes for tasks or projects that are large scale. If you have large data sets, then you label and you train. But in this scenario, in this example, I'm talking about a video, so you can skip step 3 and 4. Okay. Step 5 will be to evaluate your frame per second. Is it correct? Are the steps you took according to what you just read, according to the tutorial you just watched? Okay. And then you can deploy. If you want to deploy your model, you deploy. So say, for example, it's a large scale project. For example, you want to train your detection model to be able to detect cracks in construction sites. You have your data set, the data set of several cracks, several fractures in a building. Okay, you train your data, your model on that data, and then you evaluate. After evaluation, you can deploy. Deployment means you can use it for whatever you want to do. It doesn't mean you must put it on the cloud or anywhere. You use it for whatever you want to do, be it publication. Maybe you want to publish a paper, then you publish. That's what I mean by deploy. It doesn't mean you must specifically go and deploy on the cloud or wherever, right? It means your model is ready. So this is a typical workflow I would suggest for you guys to take.
So could you talk about more about evaluation process? What are the criteria of evaluations? What
So
you do
in
basically
computer vision,
evaluations to?
yes, in computer vision, evaluation will depend on the task. So say, for example, I want to detect cracks in a building, okay? And I've trained my model on cracks. The evaluation I would have to evaluate will be how precise is this model getting me to the cracks? How precise are the bounding boxes, the bounding boxes, okay? How precise are they close to the cracks? So these are what I'm going to be thinking about. Are my boxes actually detecting cracks, or are they detecting non-cracks? Are they detecting someone's eyes? Are they detecting someone's arm? Or are they actually detecting the cracks? So there are several evaluation metrics we have to look at. For example, the MIOU, which is the mean intersection over union, precision, there's recall, and all these evaluation metrics. We have to be able to know all these things. That's why you need to know the basics of machine learning. That is where you will learn all these metrics.
Regarding these matrices, can you design your own matrix if you wish to do so?
Of course, that is when you are an expert. By that time, you must have known exactly what pixels are, because all these metrics are designed to calculate the exactness of pixels. How many pixels are being classified in a particular region under, for example, the color, the lighting? It depends on the algorithm you design. So of course, once you're an expert, you can be able to have your own metrics, but it must be rigorous and it must be scientifically backed.
Okay, good. Thank you.
So essential tools and libraries, I think you must know to be able to perform computer vision. These are the tools I use most of the time. So for example, we have OpenCV, like I've mentioned several times. OpenCV is simply a library that helps you perform some image transformation. For example, you want to filter an image, you want to perform some augmentation to an image, flip, turn, rotate, okay? It helps you to transform an image, perform some operations to an image. It's a very good and interesting library. We also have PyTorch, okay? I didn't want to mention Keras. Keras is another interesting library. I didn't want to mention it. Why? Because most research papers use PyTorch, okay? It was in the olden times that most people used, what's it called, Keras, but some people still use Keras. In short, one of my paper, I use Keras, okay? So it's good to use PyTorch, but you can also use Keras. Number 3 is Ultralytics. Ultralytics is what I just said for YOLO. YOLO is for detection, right? You can actually also use detection, but most research papers use YOLO because of its speed, okay, in detection. But if you want to go for, let's say you want to improve the architecture of a detection module, you can use either YOLO or detection, but most research papers use YOLO, okay? But they are both for detection, okay? YOLO can also be used for segmentation. There are segmentation modules as well, all right? Hugging Face is a platform where researchers deploy their code so that you as a hobbyist or as a researcher can go and perform demos, okay? It's a very good community, okay? I advise you guys to go to Hugging Face tonight or wherever you are in the morning and see what that is about. It's a very good space, Hugging Face. Then another tool will be Onyx. That's for deployment. If you want to deploy your module, you should be able to use all of these, Onyx, TensorRT, and OpenVIN. These are very good libraries, good tools that you can use to deploy your modules. Okay? Now, there was an important reason that I mentioned image annotation in the start, right? If you guys remember, one of the jobs was image annotation, right? It's because it's one of the easiest way to get into computer vision. Is for those, how many of you have heard the term app development or mobile app development? Have you guys heard that term? People who develop apps, or websites. You guys have heard that, right? Okay. If you want to get into that space, one of the ways that experts tell you to start is using UI UX. Okay, people who perform UI UX using Figma, right? That is one of the easiest routes to start that part, right? Because it doesn't require much coding experience. It only requires you to know some basic idea of what apps are and how to communicate your ideas effectively. Now, annotation gives you that leverage for computer vision. It gives you the key. It gives you an entrance to computer vision. Why? You don't really need to know how to code. Okay, you don't need to know how to code to annotate your data. You just need to know the basics. What are pixels? Okay, what gives a perfect annotation? This does not involve coding, because right now when people think about computer vision, they think about coding and all of that. Some places in computer vision don't require coding. You just need to know the basic idea and you just execute. So annotation of data set is a very good skill you can have as a student, as a researcher, okay? So there are several tools. One of the tools I use most often for not so large data sets is RoboFlow. RoboFlow, for free version, you don't have a lot of space. For example, if you want to annotate like 10,000 images or thereabout, there's a limit. You can't go past that, but it's good for you to practice. If you want to learn how to annotate data, please go to RoboFlow. It's very important, right? Also, you can see Label Studio is also good, but I prefer RoboFlow, okay? RoboFlow has good user interface, in my opinion, and it's easy to set up. Another one is CVAT, Computer Vision Annotation Tool, also good. LabelMe has been around for several years, even before RoboFlow, but I prefer RoboFlow, honestly. Yeah, but it's also good. LabelMe is also good. MakeSense.ai, also good. Also good. Please check these tools at the end. So I just want to bring this little 30 seconds video for you guys to see how RoboFlow operates. So this is someone trying to annotate school buses. Okay, very easy interface. You know, just upload your images, and after a few seconds or thereabout, depending on the size of your data set, it loads, and then this is how you annotate. Okay, very tight bounding boxes to the object or the region of interest, as we can see. Okay, so this is a very, very short demo of what RoboFlow does. Some resources. Now that you know the tools, I'm sure you are eager to learn more about computer vision. Some resources. How can you get better? You can find some code. For example, you start a project. You can find some code on GitHub. Most people here are not very conversant with coding. When you hear coding, you feel like it's mathematics, right? It's like calculus, the y, the x. You want to run away. No, please. Okay? I'm not saying it's easy, okay? I'm not saying it's easy, but I'm telling you that there are free resources for you. There is already a foundation, okay? If you want to say, for example, calculate how many people in this class, they are bored of my lecture. How many people in this class are bored? How many people want to leave this lecture right now, okay? There's a code on GitHub that is similar to this. You just need to know how to fine-tune the code. And how can you fine-tune the code? You need to know the basics of that programming language. That's why I said what? Learn the basics of Python for computer vision. Just the basics, okay? And a resource to learn that basics, I will tell you at the end, so don't go anywhere, okay? Another place to learn is through YouTube. YouTube is a free resource for everyone, okay? It's a video sharing platform where we share lots of information. Most people go to YouTube to laugh, but please, there's information there for you to start your journey in computer vision, okay? There are lots of resources. Well, in fact, the video you just watched for your RoboFlow was gotten from YouTube, okay? There's a lot of resource there for you. Another way for you to get active in this field is by going to join 𝐂𝐨𝐦𝐻 competition. 𝐂𝐨𝐽 is a platform that organizes competitions, and most of those competitions, not all, most of the competitions are paid. If you win a competition on 𝐂𝐨𝐽, you can get thousands of dollars. Yes, just because you are able to put your interest to play. For example, I remember my first year in my master's program, we were given a project for the course. We were told that for us to pass the course, we need to participate in 𝐂𝐨𝐽 competition, right? You don't need to pass, you don't need to get first prize, just participate in it. Why? It gives you that experience. Okay, and that competition was about, I think, brain tumor or something like that. Okay, it gives you that experience to know how to handle data sets, to know how to perform, evaluate your data, and compare to other competitors, and know which one is better, because there's a list of winners and those who are, there's a ranking system. So please check 𝐂𝐨𝐦𝐻𝐿.com out. Okay. Another way is to read research papers. Okay. There is a website called archive.org. It has lots of latest preprints. So for example, I write a paper today and I want to get it published. Publication usually takes, more than 4 months before your paper gets published, even if you submit now, sometimes a year, sometimes 2 years, dependent on reviewers and your work. Okay, so Archive is a place where, as a researcher, if you know your work is complete and you want it to be published immediately as a preprint, you can go to Archive. So Archive is a place where lots of latest preprints are actually published. Another place you can check is Hugging Face. I've already mentioned this. If you want to know how a particular code from a paper works, you can go to Hugging Face. Most papers upload their demos on how their code work on Hugging Face. Finally, we have communities. Very important. Join a community. Okay, join a community on Reddit, on Discord, Twitter, LinkedIn. Find a community. Even in your school, you can build a group of people who are interested in computer vision, who want to publish papers, who want to create a data set. Okay, and that's where you grow. That's where you grow. Okay. So these are resources. So I also decided to bring some resources out. Okay, the list is inexhaustive, right? There's a lot of things, but you can go to W3 School if you want to learn Python. Okay, as a beginner, intermediate, W3 School is very important. I learned a lot from W3 School. For example, Python, my HTML skills, CSS, Java. Okay. Even some ML, please check it out. You can also check some free MIT courses, okay? Free MIT courses. Also check YouTube, in particular, if you want to get very good in the field of computer vision or ML, I will suggest you check Optimistic Futurology, I think that's his name. Check it out. So these are several places. Also check the well-renowned Professor Andrew Ng. This is a very great man in machine learning. I will suggest you check him out as well. And the list goes on. Take a snapshot or a picture and we can move forward. Okay? And kind of getting to the end, I want to just give a very brief motivation to you guys. My journey so far. Okay? My background in my undergrad was in electronics and information engineering. Okay? It's close to computer science, but not so close. Okay, back there we were dealing with microcomputers, microprocessors. Okay, how to configure a microprocessor. For example, it's closely related to robotics, but not so much to Python, right? But when I came for my master's, I purposely applied for computer science. Why? Because at that time AI was becoming a thing, right? People were starting to know ChatGPT, Gemini. So I wanted to know what is this in fact? Why are we actually calling this AI? Is it juju? Huh? Is it magic? We need to know. We need to know. So when I came, it was very difficult at the start. That was when I began to improve my Python, know what is OpenCV, and that was in 2023. What year are we? 2026. A lot can happen in 3 years. That is what I'm trying to say. A lot can happen. And in just 2024 till 2025, I've been able to submit 3 papers already, 1 conference and 2 journals. So you can do it. You can do it. Okay? So this is just some of my work. And 1 is still under review, 2 have been accepted, and 1 is in progress at this point. Okay? So thank you everyone for listening. And if you have any questions, now you may ask. Thank you so much.
take a zoom. Okay.
Or can you open your mic?
So thank you very much for this session. So I have a question regarding the roadmap. So for example, as a beginner, how many months or year will it take me to be able to be maybe approximately to be able to get to intermediate or maybe advanced stage? And then the advanced stage is in two steps. Okay, maybe being a researcher or working in the industry.
Okay. So thank you. So your question is, how long will it take you to, master the basic concept of computer vision? And when you want to talk about the expert, how long will it take you to either be a good researcher or go to the industry, right? So I think it will depend on your pace. It will depend on your pace. We in academia, we have been paced by our school. Our school actually pays us by giving us deadlines, by giving us limits on how much time we can actually process information and submit, before deadlines. So it's dependent on, first of all, you as a person. How much do you want to know this computer vision? Are you hungry for it? And if you're hungry, set a deadline, okay? And I can tell you that if you want to know the basic concept of computer vision and you are focused on it, it takes you at least 6 months for you to know the basic concept. 6 months of consistent reading and applying yourself. Consistently, 6 months is okay for you, okay? And if you want, you can add my WeChat. I can send you textbooks that you can actually read. Easy textbooks that can actually get you from zero to somewhere, okay? And if you watch YouTube videos, okay, tutorials, go on blogs, search the internet, be hungry for it. If someone tells you that this is going to give you 100 million, okay, won't you do it? You will do it. But there is this mindset of, it's not going to work, let me quit. It will work. Keep doing it. I never imagined I'll be here today, but here I am, right? So you can do it. You can do it. Start from somewhere. So to give a concrete response to your question, I would say if you're very focused, 6 months for the basics and at least 2 years to become an expert. Yeah, thank you. Yeah.
It also depends on your team, the people you are working with.
Yes, yes.
Like, what about Python? You advise us to learn Python, right? So currently I'm studying civil engineering. Like, how is it going to help or something like that? Python.
Okay.
Yeah, that is my question.
Okay.
Yeah.
Civil engineering, right? Okay. So for civil engineering, I'm sure you saw the part where I mentioned construction. You guys do lots of construction, right? You construct bridges, structural designs, right? Okay. Now, what most people think about in construction is that it's just for detection of health. It's just for detection of safety vests or buildings. No. AI is doing to generation of images. Haven't you seen that? Do you know you can actually be the first person to develop an AI model that can draw your house plan in 2 minutes? It's out there, right? It's out there, right? Okay. So it's there. So Python will help you to be able to understand how to teach the computer what you want it to teach to do. And you don't have to learn Python. You can actually use C++. Okay? You can actually learn C++ as well if you want, but that is difficult. The easiest one I'm giving you now is Python because the language is very easy to understand. It's like English. Once you understand the rules, it's like mathematics, right? You know what to do. That is programming. Once you know if else, all those commands, you know what methods are, you know what's the name of that? I've forgotten the name in programming, right? and functions, right? Once you know all these things, you'll be able to communicate better, to your computer using Python. So it's easy. Just go through W3 school. It will change your life. W3 school changed my life. So please go through it. Yes, please.
It's not a question. I just want to add on what you said, because we talked about like application of this computer vision in civil engineering, right?
Yes, construction.
So as we all know, though I'm not a civil engineer, I'm mechanical engineer. There's a vibration. It's like sometimes referred to as a hidden enemy, because it can be catastrophic. So usually some key research direction in civil engineering that you can apply computer vision include structural health monitoring, where you can identify like cracks in buildings. He talked about the cracks, maybe corrosion from images, from videos taken from your sites, particularly maybe buildings, bridges. Another application is like dynamic monitoring or vibration testing. You can use videos, images. Videos are just images.
They are frames.
They are frames, yeah. So a lot of images put together to make a video. So you can use those images to measure displacement, vibration in buildings. So those are some of the applications. Also, we have material analysis. Also, we have real-time safety monitoring, progress tracking of your construction sites. We have equipment monitoring, because there's issue of theft in construction sites. You can also use it. Also, you can use it for advanced imaging and data fusion, like drone inspection, as well as digital twins. I'm not that familiar with digital twins, so I won't talk about it. So those are few examples of application in civil engineering. So basically management, you can manage your site with computer vision. Thank you.
All right. Thank you. Thank you so much, Mr. Abdul. So any other questions? So while we take questions, this is just a more detailed tutorial for RoboFlow while we take questions, okay? Any other questions? Okay, please.
Okay, firstly, let me say thank you for the wonderful presentation. And I would like to say here that, like, we all know computer is also a discipline on itself. And for example, like civil engineering is also a discipline on its part. So for someone who is doing his undergrad in civil engineering and want to venture into computer vision, maybe in the future, so like advisably, what can you tell him? Maybe on his postgrad, maybe to go into computer science and venture into the computer vision, or he can be able to maintain himself in civil engineering and can be able to venture into computer vision with that. So what can you say on that?
Okay, so you don't need to change your field to apply computer vision. You don't. What is your interest in civil engineering? What do you find interesting? Building. Building?
Building, yes.
What about buildings do you find interesting?
Architectural parts.
Architecture, right? Okay. So you don't need to change your field to be able to apply computer vision. What you can do is to think about problems in a building that require vision. Okay. Now we just mentioned lots of problems: detection of cracks, corrosion, theft of equipment, okay, tracking of workers, who is sleeping on the job. Okay, these are things you can actually implement in your site as an architect or as a what's the term? Civil engineer, right? So you can implement all of this. So it will depend on your research. What research are you doing at that time? And is there a need to apply vision? Is there a need to monitor something? Is there a need to teach the computer how to perceive the real world? then you apply computer vision. You don't need to change your field. Okay? Yeah.
In addition to what you said, when you say you don't need just even electronics.
Yeah.
Okay, that is smart and so teaching them how to use what's tasks or how to understand structure, something like that. Those are the things. So those are
all right. Thank you so much. Thank you so much. All right. Any other questions? Okay. If there is no other question, thank you everyone for coming out today, and you can add me up on WeChat or check my GitHub for some cool codes. Yeah. Thank you so much.